Hi, this is COMP1010 at the University of Manitoba. I'm Dr. Celine Latulip. In this video, I'll be explaining how to write functions in processing that use return types. So, a function can have a return type that returns one piece of data of one different data type. So, a function can return an int, it can return a float, it can return a string. It cannot return multiple types of data. So you've already seen some built-in functions that return data. So the max function returns an int. The random function returns a float. Each of these functions return one piece of data of a specific type. Functions can also return nothing at all. So in that case, the function headers have the keyword void at the front. And you've seen built-in functions that don't return anything. Println actually prints something out to the console, but it doesn't return a value. Setup and draw both have effects. They create a canvas, they cause things to be drawn on the canvas, but they don't return a piece of data. And all of the graphic commands that you've used in processing for creating lines and ellipses and so on, those all have effects. They do something that's visible to the user, but they don't return any piece of data. So functions can have effects, things that the user can see in terms of a change in the way the program appears. They can have return values, which are pieces of data that are passed back. They can also have side effects, which are things that happen in the background that are not visible. And we'll talk more about those in a future video. So the return value is a way for a program to pass data around, and it's a safe way to transfer data. So one of the things that often confuses people is they think that printing things out to the console is the same as returning data. And these are two very different things. So let's look at an example. This function print max, you pass in two ints, it figures out which one is bigger, and it prints out the one that's bigger. So in this case, num1 would be printed out to the console. If num1 is not bigger than num2, then num2 is printed out to the console. So this has the effect of printing something out to the console, which is visible to the programmer, but it doesn't return any value back to the code that calls this function. Here's pretty much the same function, except in this case, we're not printing anything out to the console. We're just returning the value. So we're doing the same sort of calculation here, this comparison, but instead of printing out, we're returning the number. So we either return num1 or we return num2. Oh, and we're missing some semicolons here. So in this case, there's no effect on what the program looks like to the user or to the programmer in the console, but the data is passed back and would have to be stored by the code that calls this function. This third example actually does both. So print max takes in the same two parameters and figures out which one is bigger. So we're storing which one is bigger in this variable max, and then we're printing it out to the console so it has this effect that the user can see, but we're also returning the value to whatever code called this function. And so the return value is being passed out. So the return statement is a special statement in processing and in Java that says we're done with this function and we want to go back to wherever the function was called from, and it can optionally return a value. So non-void functions have to have a return statement and have to return whatever value is specified as the return type. The best style when you're creating functions is to try to only have one return statement at the very end of the function. That's what people sort of expect to see. Sometimes it's okay to have a couple of return statements at the end, sort of depending on different cases, and that's okay as long as they're close together and towards the end in a short function. What's really difficult is when you have a long function and there's a return statement buried somewhere in the middle of it that people don't really notice. So a void function doesn't actually have a return statement. There's kind of just an implicit return statement that's at the end, that's the last line of the function, that the compiler just sort of pretends is there if you don't type it in. And so we don't normally bother typing it in. So in this case, we have a return statement that's right at the end, and the value is being returned, it's max, and this value is of an int right here because it's an int variable, and it matches this return type. So let's look at a couple of examples. Here's a void draw something function, and you could actually type a return statement right here that doesn't have a value after it because this is a void function. We're not returning any specific thing. So this basically just says, okay, we're done. Return back to wherever this function was called. So you can type return at the end of a function, but it's completely optional. And so most people just don't bother because why bother typing an extra line of code that you don't need to? Here's an example, float get random. And this one has a return value. So there has to be a return statement in here, and it has to return a piece of data that matches the type of this. So let's go through an example of creating a function that returns something. So we've done a lot of this scaling thing in this class where we have a number in one range and we need to get a value in some other range that sort of matches. And so this is kind of what we call interpolation. So we can actually do this in a function, and we're going to create this function called float interpolate. It's going to take in a value, which is sort of where we are in our source range, and the size of our source range, so that we can then get sort of our percentage in the source range. And then it's going to take in the values of the sort of the minimum or lowest value in our destination range and the maximum value in our destination range, so start to finish. And then we're going to do this calculation that should look very familiar to you. So we're doing start plus this sort of percentage here, times the finish minus the start, which is the full range in our destination range. What's cool about this is because we're saying that the source value has to be a float, so you can pass an int into here, but it's going to be stored as a float, and that means that this percentage is going to be calculated correctly. We don't have to worry about integer division. No cast is needed here. So this will calculate the value in the destination range and return it. So this is going to calculate a float and return it. So now we can actually use this function. So if we wanted to draw n things around a circle, then we could have a loop here that goes from 0 to n, and we can calculate the angle around the circle, and we can call our interpolate function with different values of I. We're always, the end of that source range is n, and our destination range is from 0 to 2 pi. So 0 is the start, 2 pi is the finish. And then there's some usual trigonometry that would actually use this angle to draw whatever we wanted to do. So this does this whole calculation for us inside of a function. Okay. So let's think about the execution sequence, and we've talked a little bit about this with functions, but let's talk about it when we have return values. So when we call a function, the execution pauses. So right here, there's a call to interpolate. So execution pauses right here. We make note of this line in the code so that we can come back to it, right? And the value of the parameters are calculated. So in this case, calculating means going and get whatever I is, going and get the value of whatever's stored in n so that we know what these numbers are. 0 is just a literal, so this doesn't need to be calculated. And then 2 times pi needs to be calculated, so this is going to be 6 point whatever. So these things we have to find out what each of these values are and get numbers for them. And then the function is called with those numbers. So those values are passed into the function and assigned to the parameters in the function header. So I becomes, what was it in the last slide? I becomes, I becomes I, n becomes n, etc. Okay. And so what you have to be careful of is that the type compatibility rules apply. So I is an integer, it can be passed into a float. N is an integer, it can be passed into a float. 0 is an int, it can be passed into a float. And 2 pi is going to be a float, and it can be passed into a float. So you can pass ints into floats, but of course you cannot pass a float into an int without doing an explicit cast. So once we've got the values passed in, the function is going to create those local variables with those names that are the parameter names the programmer declared. the body's going to be executed using all that data, and the return value, if there is a return value, is going to be passed back. So it becomes the whole value of the function call. So whatever this interpolate function passes back, you can think of this whole thing as being crossed out, and that number being replaced here, and then that number gets assigned into angle. Okay, so what is important to note is that the parameters don't get passed back. That's a one-way communication mechanism. The data comes in, but that data doesn't come back out. The only thing that comes back out is whatever is passed back out as the return value. And then once that's happened, we put the value into angle, and then we continue with the execution that comes down below. So let's look at an example. Here's our function call, interpolate. We're going to calculate. We're going to get the value of I, get the value of n, calculate 2 times pi. Those values are then put into these local variables. So 12.0, this would be 60 is, we're storing that as an int, and then float 0 becomes 0.0, 6.28, which is this calculated value, gets stored in f. So this is like as if you had typed these 4 lines, but you do not need to type these 4 lines, and you shouldn't, because the compiler does this for you, right? And then we do a calculation here. So we're going to jump down here we're going to make note of this spot. We're going to jump down here, and we're going to then do this calculation. So this calculation would generate the number 1.256. We're going to use that as our return value. So it's going to replace this whole thing. So this whole thing becomes 1.256. That gets assigned into angle. And so you can see our execution sequence now we can complete the for loop and keep going. So one of the things you need to think about when you're using functions that return values is that typically you need to create a variable of the correct type to capture the result of the function. So if we have a function that has this signature, it is called random, it takes a float, it returns a float. If we want to use this function, we need to create a variable like float my random number so that we can capture the value of that. And then we assign the whole function call to this. So this has to be float because the float is the return type here. Here's another example. If we have a signature of a function that returns a Boolean, it takes 6 int parameters. Then to call this, we would do something like this. Boolean inside box equals is inside, and we pass in some data. And then when this comes back, the result of this will be saved to this Boolean variable. So again, this type has to match. So we use the terms header and signature, and I want to just clarify what the difference is. So header is the first line of code in an actual function definition. And you could consider the header as including this curly brace or not, because sometimes people put the curly brace on the next line. That's a style issue. But the header is the return type, the name of the function, and for each parameter, the parameter type and the parameter name. So int x, int y. That's the header, and it's the first line of where the function is actually declared without the body. The signature is sort of an abstraction of the header. It's used by the compiler to match function calls to know which function is meant. So it just has the return type, the name, and the types of the parameters without the names. All right, so remembering that functions can only return one piece of data, let's look at a couple of examples and look at what happens with the return statement when there are multiple return statements. So the return command, you should remember, ends the function and returns to where we noted the function had been called from. So we're going to pass the data from the function back to the caller. And what I want to point out here is that the return command, if it's in the middle of a function, statements that are after it don't get executed. So let's look through this example here. If we have this in a draw statement, we're calling this get% function, which is down here. We're going to call it with 5 and 20. So in this case, we mark this spot, we come down here into get%, we have a check to see is the second number passed in 0, because that would be bad. We don't want to do divide by 0. In this case, we passed in 5, we passed in 20. That's not true. So we don't execute this stuff. So we skip down here, and then we come down to this return statement, which actually does the calculation. It casts y to a float so that we don't do integer division, and then returns x divided by y. So 5 divided by 20, in this case, it would return 0.25. And then we come back up here, we've returned 0.25, that gets assigned to z, and we print z, and you can see we've printed it down here. In this second example, we pass in some bad data. So we say get the percent of 3 over 0. And we come down into our get percent. Our local variable x has 3, our local variable y has 0. We do this if check. Does y equal 0? It does. This is true. So we come in here and we have a return statement, an early return statement that says return -1. And this is so that we don't actually try to do a divide by 0 and cause our program to crash. So we return -1. What happens in this case is execution. We've started here. We've jumped down to here. Okay. We've come in here. This is true. We've come in here. We come down here. We hit a return statement. Now our execution, we do not do this stuff down here. As soon as we hit this return statement, we jump back up to here, and then we're going to assign the -1 and print it out. And you can see the -1 is assigned here. So as soon as you hit a return statement in a function, you do end up returning back to where the function was called. And if there's other statements further down in that function, those statements do not get executed. All right, so imagine we want to practice this. We want to write a function, and it's going to return the larger of two numbers. So imagine we want to have this function called myMax. We're going to pass in two ints. We're going to return whichever one is bigger. The header format is going to look like this. And so there's a couple of different ways that we could do this. So here we go. So we could do it this way, where we say if A is greater than B, then return A, and else return B. So that's one way that you could write this, and this will work. But there's another way that you can write this, and it looks like this. So we have myMax int A, int B. We create a result value to return, and we assign it to one of these two. So we're just going to assign it to A first of all, and then we check, well, actually, should it be assigned to B? If it should be assigned to B, we change it to B, and then we return the result. So these both actually work. They do the exact same thing. The question you might want to ask is, which one is better? And a lot of people would say that this one on the right is better because we only have one return statement. And this one has two return statements. So it's just having one return statement makes functions easier to look at and understand. And when you go back and edit those functions, you're less likely to have problems because of having extra return statements that you don't notice and that might skip statements afterwards that you actually wanted executed. So having one return statement as the very last thing in your function is best practice if you can write your code to do that. Okay, so that's everything for functions with return statements. Thanks for watching.